You're looking at a so-called freezer farm run by UPS. They can be used to store vaccines like the one from Pfizer and BioNTech, which must be kept at super cold temperatures. Trane Technologies, whose Thermo King system is used to transport vaccines, medicines and food, is also stepping up to the challenge. It's a giant in climate-controlled technology with 36,000 employees, over 880 facilities around the world, and sales in excess of $13 billion. And I'm pleased to say Mike Lemack is the company's chairman and CEO, and he joins us now. Mike, your company itself is fascinating and your footprint's huge, but I do want to hone in on your cold storage technology solutions. Just give us a perspective here on how big the challenge of distributing and transporting these vaccines is.
Well, it's great to be with you, Julia. I think it's been daunting over the past year. We think about our own just health of our family, our coworkers, ourselves, and I also think about the 1.7 trillion square feet of space that, particularly in the Northern Hemisphere, that people think about indoor air quality difference. So as we get to the cold chain and moving vaccines, it's daunting, but I think in some ways I'm very optimistic that we've got this worked through and the complex logistics are going to work well.
I mean, I want to go through some of that, but I just want to give people a sense of, to some degree, the challenges that already exist. The World Health Organization says 20% of temperature-sensitive stocks are damaged during transportation. 25% of vaccines end up degraded due to breaks in the cold chain. Mike, when we're talking about trying to keep a vaccine at, minus 70 degrees Celsius, does that pose even greater potential degradation challenges?
Yeah, Julie, when you think about the temperature on Mars is minus 60 degrees, the fact that you're actually developing technology at minus 70, even minus 80 C, close to 96 degrees below Fahrenheit, it is very, very challenging to do that. And we've not moved vaccines, we've not moved anything to this magnitude really ever in the world. And particularly as the mRNA vaccines are established, and those are the vaccines that are needing to travel at these really sub-freezing temperatures, that's where we've been focusing a lot of our attention. I think the infrastructure is in place around the vaccines that are minus 20 to 30 degrees Celsius, and of course, there's refrigerated vaccines that are 2 to 8 degrees Celsius. But the focus, the bottleneck, the innovation has really come in that ultra-low freezer temperature, and that's, again, where we've been putting a lot of our focus and energy to make sure the capacities are there to meet the demands.
What's the degradation risk then? If you're saying that the traditional transportation is around minus 20, minus 30, and if we're talking minus 70, it's clearly got to be more than potentially 25% if we get it wrong.
Yeah, and as the mRNA, vaccines are out there at minus 70, minus 80, you can see as much as minus 50% reduction in the yields of the vaccines actually making it into inoculation into somebody's arms. So you have to be very, very careful about this. So we have to map the entire process from when the manufacturer packages all the way through to when the shot comes into your arm and the various breakpoints along the way. And so, anytime it moves from, air to a terminal, through customs perhaps, out to a truck or a trailer, those are all potential breakpoints. And so actively managing, actively looking at temperatures and humidities and whether or not the chain of custody has been broken in terms of doors being opened on these units is very, very critical. There's also the combination of that plus dry ice, and dry ice plays a factor here. And I don't think the world has ever seen the volume of dry ice applied to a situation like this. And so there are challenges, again, with even dry ice used, as a partial mitigation around keeping temperatures low for longer.
Yeah, I mean, dry ice produces gases as well, doesn't it? CO2, I believe, and it burns. So even just handling large quantities is a problem. But what worries me is what you said about the 50% potential deterioration here. That takes an efficacy rate of 90% down to 45%. So we have to be really careful. Talk to me. I'm sure you're working and talking to governments all over the world. I don't know whether you'll be able to tell me if you're part of Operation Warp Speed, but you can play coy if you need to. Mike, how prepared are people? Is there anything that concerns you in how prepared and the conversations that you're having, I know, with governments?
Yeah, Julia, I tell you, it's been interesting because we at Thermo King have the entire cold chain, so I've had a bird's eye view into all aspects of how these vaccines might move at different requirements. I'm also chairman of the National Association of Manufacturers, and here there's 14,000 manufacturers from the very largest to small. including pharma companies and technology companies and logistics companies, and the degree to which people are working together to support this, to support COVID in general and essential work, but specifically around vaccine production and the ability to move it. There's a high level of optimism here for me. But when you think about the problem, and the need might be 5 billion to 15 billion doses of a vaccine around the world over time, this degradation factor is huge. And so moving from 50% to 30 to close to zero in terms of the loss just means you're going to save people's lives. And so this is a very serious issue for us, and we think about it relative to our purpose, more so than we do as an opportunity, a short-term opportunity. We don't want to be the bottleneck in getting this vaccine, into people and helping save lives. And so we're very focused on all of these breakpoints. We're talking to all governments, and there are different points of readiness. There are different strategies around how they're going to address their population. And so it's a complex, not only logistical puzzle, but also working with governments directly. We want to be sure that we're selling the product to the people that really do need it, that really have something ready to go, because there is capacity limitations that we want to be careful that we're getting this to the best place fastest around getting people inoculated quickly.
Such a great point. Once the vaccine's ready, you've got to make the choice based on timing of vaccine prepared and readiness and safety checks with the technology to get it where it needs to go. Mike, I'm glad you're the man in charge here.
And Jill, even with vaccines, you pull them out of deep freeze, you might only have 6 hours between the thaw process and the actual inoculation. And so it's a very tight window that needs to be managed at all points in the supply chain. One of them is just the storage that would be required on site. We developed a very specific container for this purpose that can store as many as 60,000 doses. And you think about, in vials, I should say, 3 to 6 doses per vial, compared to something in the market today, which might be more like 1,000 vials in a unit that might be the size of a residential refrigerator. That would be very common for a large hospital, in fact.
Makes sense.
Getting these huge systems that are mobile is very important.
Mike, come back and talk to us soon. I'm running out of time, but I'm being told off, but I'm continuing to talk to you. Mike Lemack, come back soon, sir, and thank you for you and your team's work. Chairman and CEO.
Thank you. Stay safe.
Trane Technologies. Great to chat to you.